Hi everyone, my name is Melanie and this is the poster presentation for our paper, Are All Marine Species Created Equal? Performance Disparities in Underwater Object Detection, accepted to WACV 2026. First, we'll have a look at our motivation. Even though healthy oceans are essential for life on Earth, they are still facing significant threats by humans. Underwater object detection is a crucial tool for more effective monitoring and sustainable oceanic resource management. But performing accurate detection in underwater imagery is very challenging, in particular because the images are degraded and marine organisms tend to be clustered together, occlude each other, can be very small and blend into the background. So it is very hard to find clear object boundaries. This seems to be a bigger problem for some species compared to others. Previous works on the Detecting Underwater Objects or DUO dataset report significantly lower performance on the scallop class. Most studies don't address this gap, but a few of them attribute the underperformance to the number of training instances. This seems reasonable when looking at the class distribution in DUO. Echinids dominate the data, but scallops are a clear minority. On the other hand, when simply looking at an example image, echinids are also naturally easier to spot, whereas I was quite unsure what and where the scallop is. As far as we know, no one has conducted a systematic analysis yet to investigate where persistent performance gaps come from, whether it is because of data quantity or because of inherent visual characteristics of the targets, which is crucial knowledge for mitigation. So now, let me explain our method to investigate and fill that gap. We break down the detection process into separate localization and classification stages. We first use YOLO11 as class-agnostic detector on single-class versions of DUO, and then employ Resonate 18 as classifier on single object crops of the images. We mostly rely on standard evaluation metrics, but also incorporate the TIDE toolkit in localization to categorize errors and calculate the loss in AP caused by a specific type. Amazing, so let's now dive into the results. The localization results show large performance gaps in the original data, indicating that class-specific disparities are strongly pronounced. Of course, this can still be due to the imbalanced training data, but these gaps persist in the balanced setup too, which means that data quantity alone cannot be the only explanation, but species-specific intrinsic features must have an influence. When we reduce the available training data, performance generally declines, but starfish, for example, depend way less on abundant training data, whereas holothurian decline much stronger and scallops rely on certain samples, which indicates that the model cannot learn characteristic scallop features as easily. We also find that the generally most common error is completely missing an object in any class, while there are basically no localization errors. And the decreasing gap between AP values with higher IUU threshold shows that bounding boxes are placed similarly well for every class. That's localization done. So now on to classification. Classification performance is generally really high with smaller gaps. Yet we notice that for strong minority classes like scallop, balancing training samples drastically reduces precision but increases recall, making imbalanced setups more suitable for commercial tasks, but balanced for conservations when we never want to miss an invasive species. When we reduce training data for one class at a time, performance in most class lists mainly changes with their own data. But scallops are affected in any case, which indicates that they have less distinctive features and rely on negative examples from other classes. Okay, so now overall, our key takeaways are that non-quantitative, species-specific intrinsic factors play a critical role for detectability. Gaps are mainly due to localization, where foreground-background distinction is the main bottleneck. In classification, fundamental precision recall trade-offs and interclass dependencies are revealed that inform application choices. We confirm our results through architectural ablations and RUOD as additional dataset to offer a valuable foundation for future work. Feel free to check out our longer video on YouTube or email me with any inquiries. Thanks for watching.